Welcome to section 3.6, Prove Theorems about perpendicular lines. So one objective today, to use properties of perpendicular lines. So all these theorems that we see today, really you want to use them and recognize them when proving perpendicular lines and information about lines. So let's get through our theorems and I'll have you practice a little bit. So first theorem, if two lines intersect to form a linear pair of congruent angles, then the lines are blank. So if I draw this, if I have two lines, they intersect to form a linear pair of congruent angles. That means these two angles have to be congruent. Well, then hopefully you can see that these lines will be perpendicular. And you use this upside down T to note perpendicular. The reason I know that is because if it's a linear pair, linear pair add up to 180 degrees, and congruent angles, well, that means both these angles, we can call them x. X plus x has to equal 180 degrees. 2x equals 180. That means each angle x is 90 degrees, which is a right angle. So these will both be, and according to my picture, it doesn't look like it, but it will always be true that if two lines intersect to form a linear pair of congruent angles, then they form both right angles, making the lines perpendicular. Another way, if two lines are perpendicular, then they intersect to form four right angles. Hopefully you kind of saw that building from the last example. But if I have two lines and they're perpendicular, that means all these angles are right angles. So I usually put the little box to note that they're 90 degrees. Okay, so if we look at example 1, if I see that angle 2 is a right angle, what can you conclude about angles 1 and 2? Well, let me see here that this is a straight line. So angle 1 and 2 are going to be supplementary. They're a linear pair. So that means angle 1 also has to be 90 degrees because 90 plus 90 is 180. So what can I conclude? Angle 1 and angle 2 are right angles. Angle 1 is congruent to angle 2. And that's all because the two lines are perpendicular based off that little square. Okay, a few more theorems. If two sides of two adjacent acute angles are perpendicular, then the angles are. Okay, let's look. If two sides of two adjacent angles are perpendicular, so there's my 90 degree, then the angles are going to be complementary, which makes sense. That means the angles add up to 180. That C in complementary reminds you of corner, and a corner is 90 degrees. So just use this theorem, recognize the theorem. Next theorem, if a transversal is perpendicular to one of two parallel lines, then it is going to be perpendicular, sorry, try to squeeze it, to the other. Let me draw you a picture and show you. So here are my parallel lines. I note parallel with my little arrows. It's saying if a transversal is perpendicular to one of two parallel lines, then it will also be perpendicular there. You can see that by corresponding angles, actually. If this above and to the right angle is 90, that means the corresponding above and to the right will also be 90 because of the parallel lines. Okay, use that to help you. The last theorem is in a plane, if two lines are perpendicular to the same line, then they are, it's going to be parallel to the other. And that's kind of based off of the first drawing as well, just looking at it as being perpendicular first. Then it proves that these two lines will be parallel. Okay, so these last two are a reverse of each other. Let's try a couple, and then I'll let you keep going. So example 2, answer yes or no and explain. Is line R parallel to line S? Okay, when I look at that, I'm going to, for myself, get rid of line T. Completely ignore it. I'm not going to pay attention to it. How does angle R relate to angle S? Well, I see some right angles on S, but I'm seeing nothing on line R. So, do I know that they're parallel? No. Because there's no, oh gosh, I can't write. Because there's no angles marked on R. Line R, so we can't look at that. Try the next two. Is M parallel to N? And is S parallel to T? Take a moment, look at those right angles, come back when you're ready. Okay, hopefully you had enough time. Looking at M and N, just looking at these two lines, well, based off my theorem, you can see that they're both perpendicular to S. So that means then, yes, they are parallel because they're perpendicular to the same line. So yes, because both formulas right angles are perpendicular to line S. And when I think about that, I'm kind of ignoring line R. Next one. Is S parallel to T? So when we look at S compared to T, here's line S, here's line T. Hopefully you can see that they're both perpendicular to line N. They form those right angles. So this one is yes, because both lines are perpendicular to line N. And in this case, I would ignore line R and line M actually. Okay, so just focus on what is needed. So hopefully you saw your mistakes on that and corrected. Otherwise, we can talk through it in class. Okay, I'm going to do one of these for example 3, and then I'll have you do the other. What can you conclude about the diagram from the given information? Explain. So I'm told that angle 1 is congruent to angle 2. So this kind of goes like that. They're congruent. I can both call them x. I see that they're on a straight line, so I know that means they're supplementary. So x plus x will give me 180 degrees. 2x equals 180. And that each angle is going to be 90 degrees. Now we kind of talked about that before. So I'm explaining through my work. Now I'm going to write angle 1 and angle 2 are right angles. And I'm also going to write that line R is perpendicular to line S. Okay, make sure you get that written down. You'll need that for tomorrow's. Okay, please try the next example. Hopefully you gave it a shot. We were told that N is perpendicular to M. That upside down means perpendicular. So what do I know? Well, I know that 4 right angles are created. Okay, it's one of our theorems. So I can write angle 1, congruent to angle 2, congruent to angle 3, congruent to angle 4, and they all are right angles. Okay, based off the theorem, if 2 lines are perpendicular, you get 4 right angles. I can really just say that, and then I'm good to go. That's really all I can do. My explanation is in the fact that it's a right angle based off of those perpendicular lines. Okay, so today wasn't too bad. Let's see if we accomplished the objective. Use the properties of perpendicular lines. What can you conclude about the following diagram given the information below? So you're given that ray BA is perpendicular to ray BC. Notice they both have that initial point of B. They go towards A and towards C. I'm told that they're perpendicular. So first off, what does perpendicular mean? And then what can you conclude about angle 1 and 2? So first, please tell me what angle CBA is, and then what you can conclude about angle 1 and angle 2. Also, please go to extra examples on page 11. Please attempt them. It's just finding angle measures based off some 90 degree, 60 degree, and missing values, okay? So I will be checking this objective problem as well as the extra example on page 11. Good luck.